Good afternoon, everyone. So in the last class, we had discussed about the different preparation methods of aldehydes and ketones, isn't it? Now we will move to the physical properties of aldehydes and ketones. Physical properties of aldehydes and ketones. What all things we had discussed in physical properties in the previous organic chemistry chapters? Or which all are physical properties? Melting point, boiling point, then which one?
Like the bonding and those.
Bonding comes under chemical, right? Physical properties. Bonding means, yeah, okay. Dipole moment, bond length.
Yeah.
Then solubility, density. Okay. Then about their color, order, etc. So the same things we will discuss here also under the heading physical properties. So physical properties of aldehydes and ketones. So among these different aldehydes, the first member that is methanol. Okay, the first member that is methanol, its chemical formula HCHO. So this methanol, it's a gas at room temperature. So compared to other aldehydes, this methanol, it's a gas at room temperature. And ethanol, that's the second one, that is CH3CHO. CH3CHO. That is a volatile liquid. Volatile liquid means easily converted into the form of vapors. So methanol, it's a gas at room temperature, and ethanol, it's a volatile liquid. And other aldehydes and ketones are liquid or solid at room temperature. So methanol is an example for gas. Methanol is an example for aldehyde that exists in gaseous state at room temperature. Ethanol, it's a volatile liquid, and other aldehydes and ketones, they are either liquid or solid at room temperature. Okay. This is clear? So that's about their state of matter. The next one, that's about boiling point. So this boiling points of aldehydes and ketones, that is very much greater than hydrocarbons and ethers. So when we are comparing hydrocarbons and ethers with aldehydes and ketones, this aldehydes and ketones, they will have higher boiling point than hydrocarbons and ethers. The main reason for this higher boiling point than this hydrocarbons and ethers, they have a weak molecular association that is due to their dipole-dipole interaction. Their type of bonding or type of attraction, that is weak molecular association, that is due to dipole-dipole interaction. So dipole-dipole interaction means each atom involved in that bonding that will have dipole. Dipole means partial charge separation will be there. So there will be a interaction between two dipoles. That's a weak type of force. So the bonding between these atoms is very weak. So it is easy for the liquid particles to convert into the form of vapors. That's why the boiling point of aldehydes and ketones, that is greater than hydrocarbons and ethers. Then when we are comparing the boiling point of aldehydes and ketones with alcohols, in such cases, alcohols will have greater boiling point. Okay? Yeah, Achut.
Last slide, can you show me? I copied down.
Okay. Same points are there in the textbook. Okay. Finished. Achut? Okay. So first we compared aldehydes and ketones with hydrocarbons, and in the second case, aldehydes and ketones with alcohols. So when we compare aldehydes and ketones with alcohols, alcohols will have higher boiling point. And here the reason is that they are hydrogen bonding. The absence of intermolecular hydrogen bonding in aldehydes and ketones, or you can write the presence of intermolecular hydrogen bonding in alcohols. That is the reason for the higher boiling point of alcohols compared to that of aldehydes and ketones. So the order will be like this. This hydrocarbons and ethers, they will have lower boiling point. The next one, aldehydes and ketones. Then the highest one, that for alcohols. And you have to remember the reason. For alcohols, the higher value, that is due to intermolecular hydrogen bonding. Okay, intermolecular hydrogen bonding. Clear? Is this clear? The next one about the solubility. This lower members, they are soluble in water. When we are comparing the aldehydes and ketones, the lower members are soluble in water. They will form intermolecular hydrogen bonds with water. They cannot form intermolecular hydrogen bonds between the molecules, but they will form intermolecular hydrogen bonds with water. What do you mean by intermolecular hydrogen bonding? What's the difference between intermolecular and intramolecular hydrogen bonding? Gauri, can you tell me? Intermolecular and intramolecular.
Intermolecular between molecule.
Then what about intra?
Between two molecules.
That is inter. Intra?
Within the molecule.
Within the atom or within the molecule. Okay, that is intramolecular. So here, this hydrogen bonding, that is between aldehyde or ketone with water. Okay, that's why the lower members of this aldehydes and ketones, they all are soluble in water. This is clear? So first one about their boiling point. Boiling point is higher than hydrocarbons and ethers, but lesser than alcohols. And the reason is that due to the presence of hydrogen bonding in alcohols, they will have intramolecular hydrogen bonding and intermolecular hydrogen bonding. Here, the solubility, the lower members are soluble because they can able to form hydrogen bonds with water. Okay, this is the representation of that intermolecular hydrogen bonding. This is an aldehyde, and this aldehyde will contain carbon and oxygen. And due to their polarity, there will be partial charge separation. So oxygen will get partial negative charge and carbon will get partial positive charge. And this oxygen of aldehyde, that will form intermolecular hydrogen bonding with hydrogen of water molecule. In the case of water molecule also, it's a polar molecule. So there will be partial charge separation. Hydrogen will get partial positive charge. Oxygen will get partial negative charge. So there will be an attractive force or intermolecular hydrogen bonding between the oxygen of aldehyde and the hydrogen of water. Clear? This is clear about the physical properties? Yes or no?
Yes, ma'am.
Yes, okay.
Ma'am,
Ah,
the last equation, like things happen.
last equation.
No, only that can you explain?
That's a structure. This RC double bond O. That's here. This one is ketone. R stands for any alkyl group. Okay, both R stands for alkyl group. Then CO, that is ketone. Okay, and this ketone, it will form bond with water molecule. Here HOH, that will represent H2O. So this oxygen of ketone, that will form intermolecular hydrogen bonding with hydrogen of H2O. This dotted lines, that will represent the intermolecular hydrogen bonding. Okay, the same thing is represented in the opposite side also, right side. Again, it form intermolecular hydrogen bonding with another ketone. This is clear? Achyut?
Yes, ma'am.
Yes. Shall I move to next one? Yes or no? Yes, okay. So the remaining physical properties of aldehydes and ketones, the solubility of aldehydes and ketones, it will decreases rapidly on increasing the length of chain. So we had discussed about the lower members of this aldehydes and ketones. They all are soluble in water. But when the number of carbon chain increases or the length of carbon chain increases, the solubility of this aldehydes and ketones in water, that will decreases. Okay. So the solubility of aldehydes and ketones, that will decreases with the increase in the length of chain. But in the case of organic solvents like benzene, either methanol, chloroform, etc., or all these aldehydes and ketones, they all are soluble. Okay. So aldehydes and ketones are soluble in organic solvents like benzene, ether, methanol, chloroform, etc. But they are soluble only in the lower members of aldehydes and ketones in the case of water. Okay. The next one, lower aldehydes. Lower aldehyde means the same thing that has lesser number of carbon atom. They will have sharp pungent odors. What do you mean by pungent odor? Pungent odor. Not fragrance, bad smells or very intense smell like that. So this lower aldehydes, they will have sharp pungent odors, bad smell, bad odor. Then when the size increases means when the number of carbon atom increases, or when it comes to the higher aldehydes and ketones, this odor becomes less pungent and more fragrant. So the lower members, they will have a pungent odor, but it comes to the higher aldehydes and ketones, they will have more fragrant. So these are the physical properties of aldehydes and ketones. Okay, the main thing, first one about the boiling point, then the second point about the solubility, then third one, that's about their order. Okay, is this clear, children?
Yeah.
Okay, Nandana, will you please read these points?
The solubility of aldehydes and ketones decreases rapidly on increasing the length of the chain. Aldehydes and ketones are soluble in organic solvents like benzene, ether, methanol, chloroform, etc. Lower aldehydes have sharp, pungent odors. When size increases, the odor becomes less pungent and more fragrant.
More fragrant. Okay. So this is clear about the physical properties. All of you, please switch on your videos. Okay, then can you tell me among this hydrocarbons, ethers, aldehydes, ketones, and alcohols, which one have higher boiling point? Evelyn, which one? Which one?
Alcohol.
Alcohol. What's the reason, Dia? Why alcohols have higher boiling point?
Because of hydrogen, intermolecular hydrogen.
Presence of intermolecular hydrogen bonding. Then what about the solubility of this aldehydes and ketones? Aditya, switch on your videos, all of you.
Ma'am, it will decrease with increase in length of alkyl
This,
chain.
okay, very good. Solubility decreases with the increase of the length of carbon chain. Then what about their order? Vidur? Which one will have pungent order? Which one have?
Lower aldehydes and ketones have pungent odor.
Lower members will have pungent odor, and when it comes to the higher members, it will be converted to a fragrant one. Okay. So that's about the physical properties of aldehydes and ketones. Then now we are going to learn the, Achu, any doubt?
No, just don't move the slide, ma'am. One more point to go.
Which one?
No, the last point I have to go.
Last point means this one, when size increases. Okay, you can write. Finished. Okay. So next one, that's about the chemical reactions or chemical properties of this aldehydes and ketones. Okay. Chemical properties of aldehydes and ketones. Among this, the first type of reaction, that is nucleophilic addition reaction. Nucleophilic addition reaction. So before enter into this reaction, you can tell me, what do you mean by a nucleophile? Nucleophile.
Nucleus boundary species.
Nucleus. Correct.
Loving.
Yeah, nucleus loving. Nucleus loving means they need to have which charge? Positive charge. They will have negative charge and they want positive charge. Clear? Nucleus loving means they want positive charge and they will have negative charge. Clear? So we already discussed about the structure of this carbonyl compounds, right? So in the structure, do you remember what about the hybridization of this carbonyl groups? Which hybridization? sp3, sp2 or sp? Which type of hybridization for carbonyl groups? Anyone? Adul?
sp2.
Yeah, okay. sp2 hybridization. Due to the presence of double bond, they will have sp2 hybridization. And you look at the structure, they will have one double bond between carbon and oxygen. And two different groups can be attached to this carbon. So due to the presence of this double bond, they will have sp2 hybridization. And when one nucleophile will be attached to this carbon, you can see it in the figure, one nucleophile that is attached to one carbon atom. And what happens? This double bond will break. Okay, when a nucleophile comes to attach on carbon atom, this double bond will break and this nucleophile will be attached to this carbon. And this oxygen that will get a negative charge. So the double bond between carbon and oxygen, it will break and the nucleophile will attack on this carbon atom. And this oxygen, it will get a negative charge. So this sp2 hybridization of carbon, it will be converted to sp3 because the double bond, due to the presence of double bond, sp2 hybridization there. So due to the breaking of this double bond, sp2 hybridization, it will be converted to sp3. Now you look at the second structure, it will have only single bonds, right? So one intermediate is formed. That is the first step. When a nucleophile attacks on the carbon atom, the double bond will break and it will be converted to one intermediate. And the sp2 hybridization, it will be converted to sp3. And these two, this carbon atom and oxygen, then the two different groups that occupy on the same plane. Okay, and this nucleophile, it will always attack in the perpendicular direction. These three, the carbon atom, oxygen, and the different alkyl groups, they are on the same plane. And this nucleophile, it will always attack in the perpendicular direction to that plane. And when this nucleophile attack on this carbon, the double bond break, carbon will get a positive charge. And by the addition of this nucleophile and oxygen, it will get a negative charge. So this first step, that is a slow step. And in the second step, one hydrogen atom or one hydrogen ion, it will be added to this negatively charged oxygen. Then the final product will be obtained. You can see here, oxygen minus, right? Then one hydrogen is added to form the final one, that is an addition product. So the same mechanism will be followed in all nucleophilic addition reaction. So when you learn this mechanism of nucleophilic addition reaction, you can able to answer the products of any chemical reaction that comes under nucleophilic addition reaction. This is clear, children? One nucleophile, it will be attached to carbon, then the double bond will break, that nucleophile attached to carbon atom, and oxygen will get negative charge. That is the first step. That is an formation of intermediate. Then again, one H plus ion, it will be added to that oxygen and the final product is obtained. And here the difference, sp2 hybridization, it will be converted to sp3. This is clear? Okay. Then we can discuss the different chemical reaction that comes under the nucleophilic addition reaction. Before that, we can check the reactivity of aldehydes and ketones. Okay. So here in this carbonyl compounds, both aldehydes and ketones present, right? So among this aldehydes and ketones, this aldehydes are more reactive than ketones. Okay. Aldehydes are more reactive than ketones in this nucleophilic addition reaction. So this reactivity of ketones, it is lower than aldehydes. That is due to two reasons. One is steric effect. steric effect of two alkyl or aryl groups. And the second one is electronic resins. What do you mean by steric effect? We had learned the same thing in that previous organic chemistry chapter. Do you remember the order of mechanism, order of reactivity of SN1 and SN2? What do you mean by steric effect? Don't remember. Okay, due to the presence of large bulky groups, the attacking reagent, it cannot able to attach the carbon. That is known as steric effect. So when we are comparing one aldehyde and ketone, I will write one example here. HCHO. This one is an example for aldehyde, right? HCHO. And similarly, I will write one example for ketone. CH3COCH3. So when we compare these two structures, in the case of ketone, it will have two CH3 groups. Okay, two CH3 groups. So this carbon atom, it will contain 3 hydrogen atom. Similarly, this carbon also contain 3 hydrogen atom. So here, when we compare the structure of aldehyde and ketone, in the case of ketone, it will have large bulky groups. So it is very difficult for the nucleophile to attack this carbon due to the presence of this large bulky groups. But in the case of aldehyde, only 2 hydrogen atoms on both sides. So it will be very easy for the nucleophile to attack this carbon. Clear? So that is known as steric effect due to the presence of 2 bulky groups, maybe alkyl groups or aryl groups. Okay, so that is the first reason. Then the second reason, electronic reason, means that aldehydes, it will have more reactivity towards the nucleophilic addition reaction compared to that of ketones. Okay, because hydrogen is present there in aldehydes. In ketones, this alkyl groups will have a less tendency for nucleophilic addition reaction. So these are the two reasons for the less reactivity of ketones compared to that of aldehydes. Or aldehydes have higher reactivity towards this nucleophilic addition reaction than ketones. This is clear? So these two are the major reasons for their reactivity difference. First is steric effect. Second one is electronic effect or electronic reasons. Any doubt, children? This is clear? Yes, okay. Next, we will move to the different examples for this nucleophilic addition reaction. So you have to remember the mechanism of nucleophilic substitution reaction. Then only you can able to write the product. It's very simple. Only two steps. Okay. So the first one, addition of HCN. Addition of HCN. So among this HCN, the CN minus, that will be the nucleophile. So the first step is dissociation of HCN. When they react with one base, HCN plus OH minus, it's a base, it will be dissociate into CN minus and H2O. So here the reagent is HCN, but the CN minus will act as a nucleophile on this carbon. Okay, so in the first step, the CN minus, that will be attacked to this carbon. When this nucleophile attack to this carbon, what happens? The double bond will break and the CN minus, that will be attached to carbon. Oxygen will get the negative charge. So that is the first step, and the addition product will be formed. Okay, addition product will be formed. And in the second step, H plus is added, and this hydrogen, that will be added to oxygen to form cyanohydrine. To form cyanohydrine. So in the first step, CN minus, that is attached to carbon atom, and that double bond will break and CN minus attached to carbon. Oxygen will get a negative charge. In the second step, hydrogen ion or H plus, that will be added to this oxygen to form OH. Then it will become cyanohydrine. This is clear, children? In the first step, one addition product is formed. So it has a tetrahedral shape. It is also known as tetrahedral intermediate. Okay, it has a tetrahedral shape. That's why this addition product is also known as tetrahedral intermediate. Then with the addition of H plus ion, the final product cyanohydrin is formed. Okay, that's about the first example. So here the reagent is HCN, but the nucleophile is Cn minus. So to obtain the nucleophile, it will react with a base, that is OH minus here, HCN plus OH minus. So Cn minus and H2O will be obtained. So this nucleophile, it will be attack on the carbon atom. This is clear about the first one? Any doubt? Anyone? Any doubt or clear? Tell me yes or no.
Yes, ma'am.
Yes, okay. Then the second one, that's about the addition of NaHSO3. This one also comes under nucleophilic addition reaction. So here the reagent is different, that is NaHSO3. So this NaHSO3 that is added to carbonyl compounds. So here this NaHSO3, it will be dissociate into SO3H and Na. Okay, and this SO3H that will be act as a nucleophile. SO3H. So this SO3H that will be attached to the carbon atom. Then again this double bond will break, and this oxygen, the sodium also attached. In the previous case, only Cn minus is attached to this carbon atom, right? But here it is as a reagent NaHSO3. There is no base to dissociate it into the form of nucleophile itself. So HSO3H that will be attached to carbon atom, and the sodium that will be attached to oxygen. Okay, so that's the first product. It's the addition product. This one also have tetrahedral structure. So it is also an example for tetrahedral intermediate. And in the second step, the proton transfer occurs. Here there is no addition of hydrogen. Instead of that, proton transfer will occur. So this hydrogen will be shifted to here, and the sodium that will be shifted to here. That is the only difference. So bisulfate addition compound is formed. Okay. In the first step, NaHSO3, SO3H is attached to carbon atom, sodium is attached to oxygen. That is the first addition product. Then second step, proton transfer. The hydrogen in the SO3H that will be change its position, or sodium and hydrogen, they will interchange their positions. So the final product, bisulfate addition compound, that is in crystalline nature, that will be formed. So this is the second example for nucleophilic addition reaction. So in the first case, the reagent is HCN, and in the second case, it is NaHSO3. This is clear? Second example. Okay. Then the next one, the third one, that is addition of RMGX. What is RMGX? RMGX. Which reagent? Which reagent have the general formula RMGX? Yeah, Grignard reagent. So the addition of Grignard reagent. Okay, so to the carbonyl group, this Grignard reagent is added, and the negative part that will be added to carbon atom. Then the double bond will break. Okay, the double bond will break. The negative part, that is R minus, that will be added to carbon, and this MgX that will be added to oxygen. This is clear, children? Is this image clear for you? Reaction? Yeah. Okay. So this R means any alkyl group that will be attached to carbon, then MgX that will be attached to oxygen. So the mechanism is same. This nucleophile, it will be attached to the carbon atom, then the remaining part that will be attached to oxygen. So here also one addition product will be obtained. And with the addition of water molecule, instead of this MgX, one hydrogen will replace the position. So here also addition of H plus, but the reagent used is H2O. That's the only difference. So in the first case, to the carbonyl group, this Grignard reagent is added. This alkyl group is attached to carbon atom, and this MgX that will be attached to oxygen. So the addition product is obtained. Then with the addition of water, H plus will attach to this oxygen instead of MgX. So that is another example for nucleophilic addition reaction. So the first one, addition of HCN, second one, addition of NaHSO3, then third one, that is addition of Grignard reagent. So in all cases, the first step is the formation of addition product, and the second step, addition of H plus to form the final one. Okay. So only change in the difference of reagents used and the nucleophile attached to the carbon atom and the oxygen. And what happens to the hybridization? sp2 hybridization, it will be converted to sp3. Have you completed this one, children?
Ma'am,
Yes, Gauri.
is it there in the textbook?
No, only heading is there. I think it's already learned in the chapter 11. Okay. Shall I move to next one?
Yes, ma'am.
Okay. The next example, that is addition of alcohols. This one also comes under nucleophilic addition reaction. So here the reagent used is alcohol and HCl gas. Okay, alcohol and HCl gas, these two are the reagents. And this OH group that will be attached to carbon atom, and this R group, OH is attached to carbon, and this R group that will be attached to oxygen. So one hemiacetal will be formed. Mechanism is same. This negative part that will be added to, or the nucleophile that will be added to carbon, and the other one, the opposite one, opposite ion, that will be attached to oxygen. So here you can see, to the carbon, OH group is added, and to the oxygen, this alkyl group is added. So due to the addition of these two, one hemiacetal is formed. Then again, one molecule of alcohol is added. Okay, so one molecule of alcohol is added, and this hydrogen atom that will be also replaced by one alkyl group, R dash. So it will becomes to acetal. So in the first case, hemiacetal is formed. Then again, one molecule of alcohol is added. Then it is converted to acetal. RCHOR dash, then OR dash. This one is known as acetal. Okay. That is the addition of alcohol to aldehyde or ketone. So here one more reagent, along with alcohol, we are using HCl gas. Okay. And this acetal, that is also known as gem. What do you mean by gem? Short form of which one? We had learned the same thing, the previous chapters. Gem. Geminal. What's the difference between vicinal and geminal? Vicinal means if the functional group is attached to the adjacent carbon atom, that will be considered as vicinal. And if the functional group is attached to same carbon atom, that will be considered as geminal. So here you can see this OR dash that is attached to the same carbon itself. That's why it is geminal. Okay. So for the short form of geminal, that is gem. Gem dialkoxy. These groups are known as alkoxy groups. OR. OR groups are known as alkoxy groups. So there are two alkoxy groups. That's why it is known as gem dialkoxy compound. So this acetal is also known as gem dialkoxy compound. Then one more reaction that comes under the addition of alcohols, that is the addition of ethylene glycol. The CH2OH, that is known as ethylene glycol. And here we are using HCl gas and dilute HCl. HCl gas and dilute HCl. So here ethylene glycol ketol is obtained. So this CH2 that will be attached. Here this reaction is same to that of the previous one. Only difference, this OCH2 group that will be directly attached to both carbon atom. Okay, to this carbon atom, this double bond will break, and this OCH2 groups that will be attached to one carbon atom and other oxygen atom with the removal of water molecule. So here the product is ethylene glycol ketone. The previous one it is known as acetal. Then here it is ethylene glycol ketone. So there is one more reaction that we can take in the next class. Okay,
Yes.
these all comes under the nucleophilic addition reaction. So here the mechanism is same. When you learn the mechanism, you can able to write the product. Okay, then I will take the remaining things in the next class. Children, if you have any doubt in any chemical reaction, please ask. Okay, please clarify. Then I send that notes of the previous chapter in your WhatsApp. Let me take your attendance this week. Okay, then thank you, children. See you in the next class. Bye.
Thank you.
Thank you.